Okay. Now with this one, you could use the quotient rule, but you don't have to. Simply because the easiest way to do this one would be to rewrite it. Okay, so we can make h of x equal -7 times 2t minus 3 to the -2. Okay, so now we can just do the chain rule on that one. Okay, so our h prime of x is going to equal -7. Then applying the chain rule to just that part, bring down our -2. Oh, why did I put t there? I meant to put x. (2x minus 3), and we're going to subtract 1, times the derivative of what's inside. Okay, so that's going to equal, if you wanted to, you can go ahead and combine those two. -7 times -2 is 14 times 2x minus 3 to the first power, so you can just leave that the way it is. Yes. Oh, -2, thank you. Yep, so that would make that -3. Thank you. Times the derivative of 2x minus 3 ends up being just 2. Okay, so combining those two again, we end up with 28, 2x minus 3 to the -3. Or you can rewrite that as 28 over 2x minus 3 to the third. All right. Any questions on this one? All right. And I'll start the next one on a new sheet. I should be able to finish it on this one. Live dangerously. Okay, so let's say, for example, what if we wanted to find h prime of x for h of x equals 3x minus 1 over x squared plus 3 squared. Okay. So for this one, we're going to use our chain rule. So we're going to bring down our 2 times 3x minus 1 over x squared plus 3, and we're going to subtract 1, times the derivative of what's inside. Okay. Now you could use the same trick here where you brought that up as a -1, but then you end up with a lot of negative exponents and things bouncing around, and it kind of makes it a little bit confusing. But it is an option if you want to use the product rule instead. Okay, so this is going to equal 2 times 3x minus 1 over x squared plus 3 to the 2 minus 1 power. It's just the first, so that stays. Times the derivative of what's inside. Remember, for your quotient rule, you have the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over your denominator squared. Okay, close that up. Okay. So now we just simplify that part. 3x minus 1, x squared plus 3 times, you have x squared plus 3 times the derivative of 3x minus 1 is just 3, because that becomes 3, that becomes 0, minus 3x minus 1 times the derivative of x squared plus 3, that becomes 2x. Derivative of a constant is 0, so that stays, all over x squared plus 3 squared. Okay, so now this one, we can kind of simplify this a little bit, but you don't really have to worry about the denominator, because once you multiply those two, you just get x squared plus 3 to the third. But this part you want to simplify a little bit. Okay, so 2 times 3x minus 1 over x squared plus 3 times 3x squared plus 9 minus 2x plus 2x, well, minus 6x plus 2x, 6x squared plus 2x. Because you have a negative, negative become positive. X squared plus 3 squared. All right, so once we go ahead and combine those two, you end up with 2 times 3x minus 1 over x. Actually, you can just put all that over 1 instead of making it separate, because that becomes x squared plus 3 to the third. So x squared plus 3 to the third times negative 3x squared plus 2x plus 9. Or if you wanted, you could put the 2 up there. It doesn't really matter. All right, and that would be your final answer. All right, any questions on that one? How'd that get mixed up in there? That should actually be back here. All right, so let's say, for example, here, if we're given h of x equals 2x minus 3 to the 6th, we want to find our second derivative. Okay, so the first thing you have to do is find our first derivative. So our h prime of x, we're going to bring that 6 down to the front and subtract 1. And we're going to multiply that by the derivative of what's inside. Okay, so that's going to equal 6 times 2x minus 3 to the 5th. Derivative of 2x minus 3, that just becomes 2. So we end up with h prime of x is equal to 12 times 2x minus 3 to the 5th. Okay, So now we have to find our second derivative, which is just the derivative of the first derivative. So our second derivative okay, so we make that equal the derivative of 12 times 2x, we'll make that a little neater, minus 3 to the fifth. Okay, so we can actually just factor out that 12. Okay, so we go ahead and bring down our 5 times 2x minus 3, and we subtract 1 times the derivative of what's inside. Alright, so that's just going to equal 12. Oh, we could have multiplied that, but we'll wait till the end. 5 times 2x minus 3 to the fourth times the derivative of 2x minus 3 is just 2. Okay, so we go ahead and just multiply all of those since they're just numbers. 12 times 5 is 60, times 2 is 120. So we get 120 times 2x minus 3 to the fourth as our second derivative. All right, so it's just repeating the chain rule twice. All right, any questions on that one? All right, leave that up for a few seconds. Excuse me. Keep it up. All right. Okay, so this one's just a little bit different. And we'll see now the first derivative is pretty much the same, but when you get to the second derivative, it's a little change. Say if you're given h of x equals 4x squared plus 9 to the sixth. Find the second derivative. And we clear that up a little bit, since that should be to the sixth power. Okay, so we just have to find our first derivative. H prime of x is equal to, we're going to bring our 6 down. 6 times 4x squared plus 9, subtract 1, times the derivative of what's inside. Okay, so that's going to equal 6 4x squared plus 9 to the fifth times the derivative of 4x squared. If we bring down the 2, 4 times 2 is 8, subtract 1, derivative of 9 is just 0, so that disappears. Okay, so we can go ahead and just combine these two. So our first derivative is equal to 48x times 4x squared plus 9 to the fifth. Okay. Now this one's a little bit different only because in order to find the second derivative here, we have to use the product rule. Because you notice on the one before, after our first derivative, there was no x there. So all we had to do was just worry about the derivative of that one. But on this one, you have that x here. So the derivative of that one, you now have to use the product rule. Okay. So our product rule, you have the first times the derivative of the second plus the second times the derivative of the first. Put a little multiplication there. All right. So that's going to equal 48x times the derivative of this. You're going to bring down the 5 times 4x squared plus 9. And then we subtract 1 times the derivative of what's inside. Okay, so remember, this is just all of this. We haven't even done this one yet. Okay, so that's plus 4x squared plus 9 to the 5th times the derivative of 48x. That x just disappears, and that becomes 48. Okay. So now if we go ahead and just simplify this, we have 48x times 5, well, might as well use the brackets so we won't have a bunch of parentheses laying around. 5 times 4x squared plus 9 to the 4th times derivative of 4x squared plus 9, bring that 2 down, that becomes 8x. Derivative of 9 is a constant, so that's 0. Plus 4x squared plus 9 to the 5th times 48. Okay, so here's the part you really want to pay attention on because it can get a little bit tricky. If you notice here, for both of these terms, you can factor out a 48 and you can actually factor out 4x squared plus 9 to the 4th power. That would completely disappear, and that one would just be 4x squared plus 9 to the 1st power. Okay, so you have 48 times 4x squared plus 9 to the 4th power. So these, you already factored them out, so I'll just run a quick line through them. This, you factored that out, so run a line through it. And this just becomes to the 1st power, because you can only factor out 4 of them. Okay, so that leaves this times 5 times 8x. If we multiply those two, it'd be 40x plus 4x squared plus 9. Oh, actually, I could have left that there. Okay, so actually all of this is multiplied to that because we did factor those two out. Okay, oh, where is it? Actually, that should be 40x squared. Forgot about the x there. Let me clear that up a little bit. Yep. Okay. So once we go ahead, and that looks a little bit, let me clean that up some. There we go. So we can go ahead and just combine those two. We'll have 48 times 4x squared plus 9 times 44x squared up to the 4th plus 9. Okay, so normally this step here, that's where you can tell if you messed up somewhere before, because you should be able to factor out something from these 2 points. I mean, those 2 terms. All right. Any questions on that one? All right. So let's say, for example, we had given h of x is equal to 2x plus 6 to the 5th power, we want to find our second derivative. All right, I'll give you a few moments to start on that one, and I'll leave this one up as high as I can to kind of give you a reference. Oh, wrong one. Did I move that one over already? Oh, I think I moved it, put it in the wrong section. Oh, this one's different. No way. Never mind. That one's more like the first one. So that one's similar to this one. Now with this one, you won't need the product rule to find your second derivative. Oh, yep, just need your name.